everyone. Thanks for joining. My name's Amber. We're joined today by Mike Stefferson from Cerebral. We're going to be talking about some of the Cerebral use cases, kind of Mike's transition into machine learning. And if there's any questions from the audience, we're happy to take those as well. Mike, thanks for joining today.
Yeah, thanks for having me.
Yeah. If you could give everyone a brief introduction, just to, I guess, name, role, and then a brief background.
Cool. Yeah. So as you mentioned, my name's Mike Stefferson. I'm currently based out of Boulder, Colorado. I'm working as a machine learning engineer at Cerebral. Today's my 1 month anniversary of starting there. Before working at Cerebral, I worked for a company called Manifold for about 3 years. And for that, I did the Insight program with you. Yeah, we're in the same cohort. And actually, my new boss at Cerebral was our advisor, Matt, from there. So, but yeah,
small world in tech, always a small world.
Very much so. Yeah. Before that, my background is as a physicist, or is in physics. So I did a PhD program that finished up in 2018. I did computational and theoretical biophysics, mostly doing Brownian dynamics simulations and solving equations of motion using computers.
Awesome. And do you think having a physics background helped in the roles as machine learning engineer?
Yeah, well, I'm pretty biased, but I definitely think so. I sort of, my research was not very related to ML at all, but I found the transition to data science pretty smooth one. I think a lot of the math I was already pretty familiar with. And I think a lot of problems in sort of data science, it's not always as straightforward as a lot of software engineering tasks, although there are different challenges with software engineering where it can be a little bit more open-ended. And I think kind of approaching it a bit more of a research problem and having experience doing that of it's not really clear how you're going to go from point A to point B is helpful.
Yeah. Okay. And besides the money, what's the biggest difference from going from academia to industry?
Yeah. Yeah, great question. People are actually paying attention to what I'm doing. Or I don't know, I feel in in grad school I would spend 2 months kind of going off on my own and thinking about things and testing things. I think there's in industry it's a bit more focused, it's a lot more clear what project I'm working on or what product we're building. And so there's a lot more support and working as a team to be okay, we actually need to get here by this date. Let's actually create a plan and try and execute against it.
And when making the transition, I guess, what did you have to prepare for the most? Because there's you have the problem solving skills, there's the critical thinking aspects, already getting into coding, but what's kind of a critical step, because there are a lot of folks that are in our community that have an academic background and they're looking to start interviewing. What was the biggest kind of gap for you that you really had to work on to get that first job in industry?
Yeah, I think for me personally, I feel this became more clear to me when I was working at Manifold and doing interviews for different clients and kind of contrasting that with myself when I was applying. Is I was familiar with the concepts, but I think there's just sort of it's almost talking the talk a bit that I didn't really there's like all of these things that like, maybe when I was first applying, like I wouldn't have been able to tell you like what precision or recall was, but I like understood, the like concepts. And so, yeah, so there's sort of things like kind of like the lingo that is used in ML. And I think another big one for me was like understanding systems and like how do all of these like applications actually work. That was, I'd actually say probably that was the biggest gap, now that I think about it. Whereas like I didn't do any of that. Like I wrote a lot of code in grad school, but I didn't really know how APIs worked. Like I didn't really understand, like I knew of databases, but I didn't really know different types of databases and sort of all of those things. And it's not too hard to learn that things. It's hard to get that exposure, I think,
Right.
coming from academia.
Yeah. Yeah. Like the exposure, like, and that's what we see a lot too. Like, but the Arize platform, it's monitoring models in production. And I remember folks like, like during these interviews, like always getting asked, have you put a model into production? It's hard to like get that kind of experience. Do you have any like best practices for like when you're working on a model, like making sure it's ready to go in the real world?
Yeah, like in an industry setting, or what would
Yeah.
I recommend for?
Yeah. So like, yeah, when you're building a model, just like best practices there, like so that it can kind of handle being in the real world and, not putting it into production on Friday night and
Yeah. Yeah. I mean, I think definitely just being at a place like it really depends on the project, but there's usually some sort of baseline metric that you're trying to, achieve on some test set or test sets where that's like, okay, like we have some baseline, pick the relevant metric here of like accuracy of 80%. Understanding, obviously knowing that you've hit that, and also understanding how you can typically back test on like in time to sort of have a better sense of, do I expect this to be stable, yes or no? Because things can change, right? Your distribution of data can change. So having some confidence, I think, and really thinking about like what possibly could happen before you release. And once you do, yeah, you need to have you need to be looking at what's going on and making sure that it's not, it's doing as expected. And also having an ability to pull the plug if you need to. And depending on, it depends on, what the clients of your like live model are, but yeah, having a way to like revert to.
Yeah, that's interesting. You said like, being able to pull the plug. Do you have any like examples? Because I mean, people get attached to the models that they spend a lot of time on and that they put in production. And then you're saying like, for I guess for like if you're like contracted to like build these types of models, it may not be what the client wants, or even in companies like you might have to scratch everything you're doing and restart. Whereas in academia, you kind of just keep pursuing things, keep writing it all down because it all turns into something like at the end. Whereas sometimes you experiment, it leads to nothing. Like what kind of goes through your head in that process, or like things you remind yourself to make sure that, you just move on past it.
Yeah, I mean, I think for like a processes standpoint, it's good to have like, you can establish some metrics that you're, monitoring around. And, if it does fail, like you can revert back to, I don't know, sort of like feature parity to vote before your thing goes live. So in a lot of cases, that's like, there was some rules engine that was, producing some outputs maybe, and you can revert back to that. So like that's from the process standpoint. As far as like, yeah, I don't know how to handle that as like the creator of the thing was maybe another part of your question.
Yeah. I guess you kind of like I mean, everything's a learning experience too. Like, so even if it doesn't work, like you still learn from it, and can kind of, you use what you learn to build like a better model that you're even more proud of next time.
Yeah, I think that's pretty spot on. Like, I think that presents itself if things happen, if something happens live that you weren't expecting, there's probably a really good learning from that. And that learning could be there was some edge case you weren't really thinking about. Maybe your model had bias you weren't concerned or you weren't aware of, or maybe the data, I forget what they call this, but like the data you're used for training is just following a different distribution than what you're seeing live. Like all these things can happen. And so, yeah, hopefully you can learn in next time.
Yeah.
Be prepared.
Yeah. You can also get Arize and monitor for drift, performance, data quality, sustainability. Not a shameless plug at all. And so, Mike, like coming up on your 1 month, like how's the onboarding going? Because I guess you were at Manifold, several years. So this is like, the first role in a while, like you had to re-go through the onboarding process. How's that?
Yeah, it's good. It's been an interesting experience, like onboarding fully remotely. That's been like a new, sort of a new thing for me. And, I think that there's like a lot of pros with remote work, but, I think it's hard to like, whenever you're working, like it's important to have trust between, who you're working with. And I think that's just like a little bit harder to do remotely. So yeah, I think first month's been good, trying to get the like FaceTime over Zoom, which not my favorite. I much prefer in person, but it's good. I mean, I met a lot of really cool people. I'm pretty excited for my immediate team that I'm working with, and also the like broader team. And I think some pretty cool projects that are like just starting to work on, but yeah. So far.
And then Cerebral, like a very cool company, like cool mission statement. Can you tell us a bit about like kind of the goals of the company, and why you joined?
Yeah, so Cerebral is a telemental health company, and they offer different services based on different like mental health conditions. So, sort of think of them as call them like service lines. So there's things for depression, for anxiety, like opioid use disorder, and then the different so those are like the different so there's a bunch of different like mental health, I don't want to call them verticals, but mental health things that are treated. And then there's different services offered. So there is therapy that is offered. There is like prescription. So you could like see a prescriber through Cerebral. There's also like combination between the two. And I think they're also like releasing and like coaching and all this other different like product lines that I should probably know more about, but still learning.
Okay. And then what made you want to join the startup?
Yeah. So from working at Manifold, I had worked a bit in healthcare for different companies, and I really think there's like a huge opportunity for like data to help here. There's not just data, but also like software. Like I think there's a lot of inefficiencies that can be made better, and I really think that we can like leverage data to actually like, really know if we're making like clinical improvements for patients and like actually moving the needle in like meaningful ways, which are like directly affecting people's lives, which I think is super cool and a great opportunity.
Mm-hmm. And you're talking about some exciting projects. Any you can tell us about?
I think I can kind of like broad strokes. So Cerebral has like a like a clinician facing application and like a patient facing application. There's like projects that kind of touch different, the different sort of apps. I'm starting to work on the clinical side. So implementing some tools to help with like clinical prescription, like monitoring and safety. So, really like trying to make sure that like best practices are being upheld on the prescription side.
Okay. And in terms of best practices in like model development, choosing the right model, building from scratch versus like retraining an existing model, how do you go about that process of selecting like the best model for your use case?
Yeah, I think given the like recency of working at Cerebral, I can't really talk in terms of like what we've done here because I just started. I haven't gone through that process, but yeah, usually it's like a pretty good, I don't know, the way I think about it is like for most projects, there's typically some like domain expert who may not be familiar with ML, but has a better sense of like what's important. And it's kind of like figuring out what metrics should we actually care about, right? Because like for any like regression or classification problem, there's different metrics that you could measure, and some of them, they all are telling you something slightly differently, but some of them might not be as appropriate for the given problem at hand.
Okay, so kind of starting with the why, like what do we want out of this, and then finding how to get it. And if I'm a user, like how do I use Cerebral?
Yes.
If I need some mental health, like expertise, asking for a friend, like, how do I go about using the product?
Yeah, so there are two like main, or I'll say there's two main like users. One is like on the like the clinical side. So there are users who are like nurse practitioners and doctors and therapists. On, I'll call it like the patient facing side, you're mainly, you're using Cerebral as like the interface between you and like handling all your appointments, signing up all your prescriptions with the prescriber. So yeah, you would sign up and then you would have access to the like Cerebral app, which has like it's not just focused on like if you're seeing a therapist, there's also additional like tools and support in there. But that's also like your interface for like scheduling appointments, and if you're receiving prescriptions, like we like have things that send prescriptions to your house. So that's you'd use it in that way.
Mm-hmm. And like model explainability, like SHAP values, fairness and bias, like some of the topics we talked about, very prevalent, but like even more so in the healthcare industry. Are there some general best practices? Like if someone else was like at a healthcare startup and you're talking about like, things to be careful of or things to monitor, like in production, what might you say are like key things that you try to keep in mind?
Yeah, great question. Yeah, I feel like, I don't know, there's something that I wasn't super cognizant of before I started working in industry. Like I feel like when I started learning ML and data science, you're really focused on like model performance.
Right.
One thing that I've learned is that like most people, especially in healthcare, they want to know like why is that number the way it is, because there might be a dial that they kind of want to turn to maybe improve. Like, for example, if you're looking at like a health in general, like a health score of someone, and you see someone's is higher than another person's, you might want to be like, well, is there something we can do to like improve that number, right? We don't necessarily care what the prediction, we care about the prediction, but we want to intervene and make it higher. I think like SHAP is a great way to like kind of get some sense for that. I think a bit more like academic way of doing that is through like causal inference, which was also something I wasn't super aware of up until the past like couple of years, but very interesting field of like mathematics that tries to get at why. Why does, why did this score? Why is this score the way it is?
Okay. Causal inference. Is there like resources for that? Or do you build it in-house, like to try and have that aspect?
Yeah, I think for resources for like understanding, like Judea Pearl is like one of the like founders of causal inference, I would say, and like one of the main contributors of the field. He has actually a popular book, like a pop culture book called The Book of Why, which is good. He also has a textbook called Causality, which is good. It's like a grad level like textbook though, so I don't know if I'd recommend like starting there. Yeah, some other good resources. Richard McElrath has a textbook and course called Statistical Rethinking, which is like a Bayesian stats course, which talks about causal inference as well. So that's on the like understanding side. Microsoft has a tool called DoY, which is like a software package to help this.
Okay. I'm just curious, like how kind of it works, because with the Arize platform, we've patented like performance tracing, where like once an alert goes off, you're able to dive down into the individual like either like inputs or cohorts or like slices of data and see how that individual performance is impacting your performance overall. So like you see like what is bringing down your performance the most. I'm just curious like how causal inference works to like try to do a root cause analysis. Like when I think causal inference, I'm like, so if you observe something, is something going to change? Or if you don't observe it?
Yeah, I can't speak to this exactly without knowing more information, but I would imagine like, yeah, what you're seeing, it's kind of serving maybe a slightly different purpose, where it sounds like what you're describing is like you have some prediction that maybe seems kind of like unexpected, and you can drill down into like what was causing that, which is useful for like understanding what your model is doing. Where I would think of causal inference as more of like a framework for a lot of covariants are going to be like correlated with each other, and so causal inference is more asking the question of like, it's almost like asking a counterfactual question. It's like, if I were to like tune this variable in this way, how would I expect that to like change the outcome?
So it's more like in the development stage.
Yeah, so like typically when you're doing a causal inference problem, you're thinking of a causal like understanding of your problem. So yeah, it's a little bit different, but I think solving different problems, but also like both kind of useful.
Okay. Yeah, very cool. And just like, switching to the healthcare industry, like we've run like panels for AI governance, like data privacy, like AI ethics. And we're just seeing this pick up more and more, like especially in Europe, like more kind of compliance angle. And I know especially like going from, like academia to at the point where it's like you're just focused on that performance, or you're just caring about like getting the data in the first place. Like do you feel like everyone that kind of works just with data should have to undergo like some kind of training, or do you think that's going to like come up in like the future? Because obviously healthcare data like does have requirements around it, but now that data is everywhere and it's so prevalent and it's so powerful, that there might be like just training overall in the future. And this is maybe more of a philosophical question.
Yeah, no, I think it's like, yeah, I think that sounds great. I actually don't think that like building HIPAA compliant systems is not, from like an infrastructure standpoint, is not too it's not impossible, or it's not even that difficult, to be honest. I don't think there's any reason why you can't have, having the same sort of standards of like encrypting data at rest or transit for other systems. I think that's like a manifold kind of just like what we would do for everything. So it's like, yeah, it's not PHI, but it's also data, and that's like, there's a reason why like all of these big tech companies, like all of their tools are open source. It's because like all the money's in the data, right? So like making sure that's secure and safe, I think should be probably a top priority for most people. And training's, yeah, great way to get there, get part of the way there. Yeah.
And then I think it's also just, it's so new, like just all this AI being connected to healthcare industries, from like, computer vision use cases around it, NLP use cases, and like various parts. Like, how do you currently like monitor, like have best practices for monitoring these models in production? Because these models can fail silently. It might be even a while before you realize like a model is slightly underperforming. So like, are there any like tools you're using, or like, things you're keeping in mind as you put these models into production?
Yeah, I can't quite speak for Cerebral, just given how I just sort of started, but historically I have sort of like rolled your own to like keep track of things. And this could be as simple as like, writing things to S3 and, coming back and reading them like every day and making sure it doesn't like pretty janky, but like kind of gets you there. Yeah, and I know there's like some other, I think historically it's been just like roll your own, which is nice because you kind of know what everything's doing, but also like extra time. So but yeah, I know like SageMaker, I think basically has a pattern that is similar to what is sort of done before. Like they have like, if you're using AWS, they have a way of like getting that all set up for you. So yeah, you need some way to look at a graph as a starting point to see are things doing what you're expecting them to doing.
Right. And then, so we just have a few more minutes left. And a question like I always like to end on is, like working, now that you've worked for several years now, like as a machine learning engineer, now at 2 different companies. So like, what is like your favorite part, and like, what's the most challenging part? And sometimes they're the same thing. They don't have to be. But yeah, like just for, kind of like your favorite parts, and like the things that are difficult, but you always have to kind of stay on top of.
Yeah, favorite part, I just love solving problems. Like, I don't know, it doesn't, in kind of like a general sense of the term, like I don't know, I find like engineering challenges interesting. I find like data problems interesting. So yeah, I just like I feel like as an MLE, you're in like a pretty unique position where, I'm thinking about data, I'm thinking about data engineering, I'm thinking about software engineering. So it's just like a bunch of different things, which I really like. Yeah, hardest part.
It could also be solving problems.
Yeah, I mean, sometimes those are really hard. Yeah. Yeah, I don't know. I think there's additional, like, I think sometimes it's challenging. It's hard sometimes to like communicate data. I think sometimes is a challenge, especially if for like non-technical people. Like I think my default is to like, I think everyone, is like has a similar background. So, yeah, people problems can be challenging, but they're also interesting. So
Yeah, you can't yell at people the way you can yell at your
yeah, you learn that the hard way. Yeah.
All right, everyone. Well, thanks for joining. Mike, thanks so much for chatting. It was great seeing you.
Yeah.
we're at the 30 minutes, but I hope everyone has a great rest of their day. Bye, Mike.
Yeah, thanks, Amber.